Okay, let's do some more calculus. I'm so excited because today I get to make one of my favorite sounds in the world over and over again. Yes, you heard me right. It's a sound. Wow. Oh man, I can't wait to do this. Okay, let's go. The first thing, this says rules for differentiation, and it says finding the derivative of a composite function. A composite function is a function within a function. Wow. I'll get to that in a second. A function within a function. So for instance, in this one, 2x plus 3 is a function within the x cubed function. More on that in a second. For right now, what I'm going to do is just take the derivative, doing the same way that I did a couple days ago using the product rule. So I'm going to put it in polynomial form, meaning I'm going to write out f of x is equal to 2x plus 3 times 2x plus 3 times 2x plus 3. You can do this now too, but it's going to take some time. I'm going to multiply these first two binomials first. So I get 4x squared plus 6x plus 6x plus 9. And then I need to multiply that by 2x plus 3. But first, I'm going to put this together and say 4x squared plus 12x plus 9. And then I would have to distribute 2x to all of those terms, 3 to all of those terms, and I end up getting, this is after some work, so you can do this right now. But if I multiply all of these things, my final answer would be, because I've done this before, 8x cubed plus 36x squared plus 54x plus 27. Go through all the rest of the steps. You should get in between that if you want. Ooh, look at all this writing. You would get that step first, the 8x cubed plus 12x squared plus 24x squared plus 36x plus 18x plus 27, and then you get this whole mess. But, so I've got this. It takes a little while. F prime of x is going to be 3 times 8 is 24x squared. Hopefully you're getting really good at this by now. 72x plus 54. We did it. There it is. And then we could factor that if we wanted to, but let's just leave it like that for right now. And then I'm going to tell you about the chain rule. So the chain rule is this. If f is a differentiable function, so at the point u equals g of x, so we're going to have some function within a function. So if we have g of x is on the inside, and it's saying g of x is differentiable, meaning you can take the derivative at some value of x. And then f is also differentiable, so we've got f of g of x. So it's a differentiable, you can take the derivative of this function. That means, by the way, this doesn't say fog, but this is f of g of x. Another way we write this is the function g of x is inside f of x. So f of g of x is not f times g. We've got this function within another function. Wow. I'll talk about the noise more in a second, is differentiable. And so it says f of g prime of x, and usually we write it more like this, is going to be f prime of g of x times g prime. So just like all the other ones, we had the product rule, and we could say the first times the derivative of the second plus second derivative of the first, or the quotient rule where we did bottom derivative of the top minus top derivative of the bottom over the bottom squared. Here, for the chain rule, we're going to say, I'm going to write this down here, just so I have some room. Take the derivative of the outside function. So take the derivative of the outside. Leave the inside alone. Oh my gosh, my head is in the way. Now I know. Take the derivative of the outside, leave the inside alone, times the derivative of the inside, or multiply by the derivative of the inside. I often say times the derivative of the inside, so if you want to say that, then multiply sounds fancier. Okay, so if we're going to apply this to this function, do you see how I've got f of x? So it doesn't say a function within a function, that's okay, f of x, but I have a cubic function. And then over here, I'm going to write in a different color, 2x plus 3 is a function. So I have a function within a function. And the reason why I keep saying, wow, is because there's a movie called Inception. Inception it has Leonardo DiCaprio in it, and it's kind of old, and usually the last couple of years not many people have seen it, but it is this thing where it's a very intense movie. It's one of those, if you're not paying attention, that you're gonna miss a lot of things, and you probably need to watch it more than once. And I'm not even saying it's a great movie or I would even recommend it. There's lots of weird things in it. I'm just saying they keep talking about putting an idea in someone's head, and so they talk about going with a dream within a dream. And with composite functions, we have a function within a function, and sometimes there's a function within a function within a function, just like in the movie, there's a dream within a dream within a dream. But every time somebody is like doing this dream within a dream, there's this noise that happens. And I know I don't even need to make the noise itself, but because this sound sounds exactly like it. The sound is wow. Okay, ready? And then if you search Inception button, so INCEP, oh my gosh, TION button, you get a big button and it sounds like this. I'm hoping that you can hear it. Okay, I did it twice. Hold on. Wow. See, it sounds exactly the same. So anytime you see a function within a function, to remind you, I'm going to say, wow. So let's do this. So how you take the derivative is we're going to take the derivative of the outside function. The outside function is this thing cubed. So I'm going to say 3 squared. Because remember, you take the exponent times the coefficient, which in this case would just be 1 on the outside. Now I'm going to leave the inside alone, times the derivative of the inside. And the derivative of the inside is just 2. And then that's it. That is the derivative. So none of this work from up here. And there's some times where you can't even do the work from up there. It might not be a polynomial. And you'll see that in the next one. But that's it. This is all we have to do. So if you want to be convinced, and you're like, well, is this really the same thing as up there? What I'm going to do is I'm going to say, well, this is f prime of x is equal to 6 2x plus 3 squared. And I just want to see something. If I would say f prime of x up here, and I would factor out a 6, I'd be left with 4x squared plus, is that 12x plus 6 times 9, which becomes 6 2x plus 3 times 2x plus 3. Let's just try that. That'd be 4x squared plus 6x plus 6x. Hey, that's 12x plus 9. What? That's the same thing. So what we got down here was already in factored form. This already looked really nice, and there were just a couple steps. So this one should save you time and energy. And it's awesome because you get to make the noise. Wow, a lot. Okay, this one, oh man, find the slope of the normal line. In order to find the slope of the tangent, or slope of the normal line, we have to find the slope of the tangent line first. So the slope of the tangent line, here I've got this function, and you're like, that doesn't look like a composite function to me. But it is. Because I've got sine of theta. That's my inside function. I'm changing the colors up on this one. You know how I can write this as sine of theta squared? My squared function, like x squared is a function in itself, it looks like a parabola. Sine of theta is a function within a function. So that means, wow! I'm really hoping that you can hear that on that end. Okay, so then I would take the derivative of the outside, switching up colors because I can. The derivative of the outside would be 2. Subtract my exponent by 1. Leave the inside alone. The derivative of sine of theta is cosine of theta. And then I want the normal line, which means the slope of the normal line, which means I need to find the slope of the tangent line. also known as the derivative, at pi over 6. So f prime of 5 pi over 6 would be 2 sine 5 pi over 6 cosine of 5 pi over 6. And I know lots of people don't love this part, so if you're like, I'm good on trig values, just go on, meet me at the end for the answer. But if you're not, the way that I would do this is I think about triangles, and you might think about some other way, but I think of pi over 6, pi over 3. And I remember across from pi over 6, that's the smallest angle, this would be 1, square root of 3, and then 2. Sine, if I do SOHCAHTOA, sine is opposite over hypotenuse. So this would be 2 opposite over hypotenuse of pi over 6 is my reference angle. Opposite over hypotenuse is 1/2. And I have to be careful because I'm not sure whether that's going to be positive or negative yet. I'll get there in a second. Cosine of 5 pi over 6 would be pi over 6 again, square root of 3 over 2. And again, I've got to be careful with positive or negative because I remember all our awesome students take calculus. 5 pi over 6 is almost 6 pi over 6. So if this is 0 and this is pi, I'm thinking this quadrant. So sine is going to be positive, so the 1/2 is positive. The negative, or this square root of 3 over 2 will be negative. So this whole answer will be, this will go away, and I'd be left with negative root 3 over 2, which means slope of my normal line at theta equals 5 pi over 6 is, this is the opposite reciprocal, so I'm just going to say 2 over root 3. And if you're like, no, I definitely want to rationalize the denominator, you can multiply by square root of 3 over square root of 3, and you get 2 root 3 over 3, but there's no reason to do that now. You can just say, this is my answer. Ta-da! Let's do more chain rule. So on the next page, there's a bunch of examples. Oh. So what you need to see is what function is within another function. Wow! So I'm going to write the outside function. I'm going to write f of x is the cubic function. 3x squared plus 2 is the function within the inside. So to find f prime of x, I would take the derivative of the outside, so you'd have 3, leave the inside alone, so it'd be 3 something squared, leave the inside alone, times the derivative of the inside, which is just 6x. If it was like 6x plus 5 or something like that, make sure that you put parentheses, but since it's just 6x and it's all one term, you don't have to. You could multiply and say 18x, or you could just leave it like that. Okay, the next one, that seems funny because it doesn't look like there's a function within a function, but there is. And make sure that you're labeling. I'm saying this is g of x, so I know I haven't taken the derivative yet. This would be, I've got my function on the outside. Square root is the same thing as raising to the 1/2 power. The inside is 2x plus 5. So I have a function within a function. Wow! I can't wait to hear your noises too. Mine doesn't sound like a dying cat at all. G prime of x is equal to, take the outside function, so the derivative of the outside would be 1/2, and I'm going to go to the negative 1/2 power. Leave the inside alone, times the derivative of the inside. And then in this one, just because there's a negative exponent, I'm going to simplify a little bit. G prime of x, this 1/2 and 2 are going to cancel out, and I'd be just left with 1 over 2x plus 5 to the 1/2 power, which is the same thing as 1 over square root of 2x plus 5. Okay, moving right along. Oh, this one looks gross. It's not so bad. Let's rewrite it. So I'm going to have something raised to a power again in this one. And the power is, if this is 2/3. So I'm raising to an exponent of 2 and a root of 3. And the derivative, or the function on the inside, is x plus 2. So h prime of x is going to be, take the derivative, oh wait, I should explain that a little bit more. So in here, if you have an exponent of 2, this is where the 2 is coming from in the numerator, but the cubed root, that's where this 3 is coming from. So if you have like a square root, that's why this one was root 2, but it had an exponent of 1, because this is all raised to the first power. That's where this is coming from. So I'm going to take the derivative of the outside. 2/3 minus 1 would be 2/3 minus 3/3, which would be negative 1/3. Leave the inside alone, times the derivative of the inside, which is just 1. I'm going to rewrite this only so that I don't have a negative exponent. So I've got 2 over 3 x plus 2. And because this is going to be the positive 1/3, I could have written the cube root. I actually prefer to leave it like this if I'm doing cubed roots, just so I'm not confused of like, is this a coefficient or an exponent, or what is this out in front? So I'm just writing x plus 2 to the 1/3. Okay, going on. This one is a cubed root again. And then there's a 5 out in front. What do we do? And a capital F of x. Oh no. We just write all those things. So the outside, this is the cubed root, also known as 1/3. And I've got a 5 out here. That's okay. The inside is this. There's a function within a function. My sound isn't working. Nope. Wow. I'm just going to make it. I take the derivative of the outside. 1/3 times 5 is 5/3. I leave the inside alone, and then I subtract the exponent by 1. So 1/3 minus 3/3 is negative 2/3. Leave the inside alone. Times the derivative of the inside. The derivative of the inside is 2x plus 2. And you have to be really careful, because when you're doing the 2x plus 2, you have to make sure that you have parentheses. The next thing is, I'm just going to rewrite this so I don't have a negative exponent. I'm going to keep 5 times the quantity 2x plus 2. That goes in the numerator. In the denominator, I'm going to have 3, because this is 3 from the 5/3, x squared plus 2x raised to the 2/3 power. And if you wanted to say the cubed root of x squared plus 2x squared, you could. Oh, we're getting into good ones. Cosine squared of 3x. I know that you're excited, but I'm going to need another marker, because this is a function within a function within a function. Wow. So what I mean by that is, on the outside, you see how this whole thing is squared. So I'm actually just going to rewrite this over here first. This is like cosine of 3x, and this whole thing is squared. So there's actually a function within a function here, within a function. Wow, wow. The outside function is just whatever is squared. Inside, I've got cosine. Cosine is a function in itself, but normally it just has x on the inside. And x, the derivative of x is just 1. It is a function, but it's just x. The inside of this one is 3x. You can barely tell, it's just a different shade of green. So what I'm going to do is I'm going to keep following the chain rule. So I'm going to say g prime of x is equal to the derivative of the outside. Leave the inside alone. There we go. Times the derivative of the inside. Now the derivative of the inside is now this cosine of 3x, which you get to do the chain rule again. The derivative of cosine is negative sine. Leave the inside alone. Times the derivative of the inside, which the derivative of 3x is 3. And I'm just simplifying ever so slightly. This 2 times 3, and then I've got a negative in here, would be negative 6 cosine of 3x sine of 3x. Beautiful. Okay, last one, but good news. It's another one like that where there's a function within a function within a function. Wow, wow. So if I take the derivative of the outside, well, actually, I'm just going to rewrite this as sine of 2x plus 1 squared. And if you don't have different color markers, what you would do is this is the inside function, this is an inside function, and then you have an outside function. So I take them and I just kind of underline them, not because that's like the mathematical representation, like you don't have to do any of that, just because it helps me remember. So I'm taking the derivative of the outside, which would be this 2, this something squared. So now it's like 2 times something raised to the first power. The derivative of the inside is sine of 2x plus 1. Or I'm sorry, I lied. Leave the inside alone. Sine of 2x plus 1. Now take the derivative of the inside. The derivative of sine is cosine. Leave the inside alone. Now I've got this 2x plus 1. You can simplify if you want, just a little bit. And you have 4 sine of 2x plus 1 cosine 2x plus 1. We did it! Oh, there it is. We did it! Thanks so much. You're great. Let me know what questions you have. And make sure you're making that noise as you're doing this. So anytime that you see a function within a function, you can make the noise. It feels good. Say it with me now. Wow! Or if there's 2 functions within another function, wow, wow. Okay, it's a good time. See you later.